Many a wafer producer worldwide has created his own unmistakable brand of hollow wafers. By way of example, we demonstrate the development of a hollow wafer form. The three-dimensional geometry is designed with the help of the CAD system. Optimizing the outer shape with regard to baking techniques, as applied later on, facilitates the release of wafer sheets. Likewise, the optimal routing for the milling tool forms part of the investigation in order to allow for a rational and economical machining of the baking plates. The geometrical data are transmitted directly to one of the milling centers, and a product sample is made out of plastic material for better illustration. After careful examination, a sample pair of baking plates is produced for test baking. Upon approval of the test result, the machining of an entire series of baking plates will be started. This will also be done naturally with the help of a system of automatic loading and unloading equipment, around the clock if necessary. The special alloy of the basic material for the baking plates, as well as the structure and the hard chrome plating of their surfaces, guarantee decades of trouble-free wafer production. Another, different and very specific form of hollow wafer is the production of spheres as shown here. Another very interesting plant composition. Already in the manufacture of baking plates, our long years of experience in the field of hollow wafer production is obvious. The correct configuration of the hollow wafer geometry and superlative condition of the baking plate surface ensure high product quality and excellent efficiency of the baking machine. After depositing the batter, the baking plates are closed and locked and travel through the baking chamber within the preset baking time. The wafer sheets are then taken off and turned over in the process. A vertical cooler is used to cool the wafer sheets. At the same time, it serves for feeding a successive conditioning tunnel on the upper floor. Securely held by special brackets, the wafer sheets travel through the conditioning tunnel. The air ducting system inside the tunnel provides for an even distribution of the circulating air. The air conditioning unit controls the pre-selected temperature and humidity. Next, the wafer sheets reach the connected spreading machine via a conveyor. Here also, depositing the filling compound is done by the film method, followed by filling up the concavities. A special feature of this particular product is the enclosure of hazelnut kernels, which get into the drum depositor by means of automatic charging equipment. A double row of hazelnut kernels is dipped into the cream-filled concavities. Every other double row stays free of nuts, so that after doubling 2 wafer sheets at a time, only 1 nut each per wafer sphere is located inside. The doubling of sheets is effected by a fully automatic doubling device. The 2 filled sheets are positioned in relation to each other with extreme accuracy and without overlapping margins by means of a centering device. In this case too, the wafer blocks are pressed together to obtain excellent adhesion between the 2 hollow wafer sheets and the filling. Prior to the punching and distribution process, the blocks are cooled. A conveyor takes the cooled down blocks to the punching machine. While entering the punching position, the blocks are halved, each half being aligned separately. By lowering the punches through the matrix, the spheres are punched out concentrically and then taken out and away from under the machine. The result? Round wafer spheres consisting of congruently positioned spheric halves. The spheres are carried forward by a transport system which frees them from wafer dust, afterwards entering the distributor via a charging unit. By means of oscillating channels, the spheres are now spaced and fanned out over the entire width of the following chocolate coating plant.